Okay, so we're looking at the transformation of trig graphs worksheet number 6, and we notice we have a couple of things going on here. I notice I have an amplitude of 2, which means it's going to take my base graph, which for cosine normally starts at 1 and then goes down 1, 0, -1. I'm actually going to keep that on here because I want us to be able to kind of see how this works. Okay, so my amplitude basically is just going to take these numbers and multiply them all by 2. So it helps me to notice, thank you, that I'm going to be going up and down a little bit higher than I normally would. The value right in front of x is my b value, which is going to change my period. On sine and cosine graphs, that period is always 2 pi. So if I take 2 pi and divide it by 1/2, and again, dividing by a number smaller than 1 makes it bigger, means my new period is going to be 4 pi. You're like, no, how am I supposed to do that? I only see 2 pi on here. Well, I have options. I could either go 2 pi to the right and 2 pi to the left, or I could try to draw some more out here and expand it and go from 0 to 4 pi. I think I'm going to do the positive negative thing here, but I could also expand it the other way. So you're like, okay, so how does this affect me with my base graph? Because now it's 4 pi. It's double what it was before. Right. So if I'm going from a period of 2 pi to 4 pi, I'm going to double all of my angle measures. So in other words, now if I was looking at making like a chart or something, and I don't need to make a chart, but just so we can see what's going on here, I'm going to double all of these, or multiply them by 2. Which is kind of nice, because multiplying by 2 gets me, oops, whole number angle values. And like we'd mentioned before, once I get the period set, that's always going to be my first job. Then I'm going to multiply all my typical y values by 2. And sometimes when you're doing multiples, it's hard to do it all in your head. So you may have to jot something down to kind of see how this works. But once I have that, then I can go ahead and go, okay, so 0, 2. At pi, I'm down to 0. At 2 pi, I'm down to -2. Now here's where I'd stop for a second. If I wanted to keep going, and like I said, I will show you both. I could look and basically equally space out to go to 3 and 4 pi, and then do it that way. But I also remember with my cosine graphs, oh yeah, they kind of make this curve kind of like this U shape. So if I wanted to go the other way, I noticed the pattern. 2, 0, -2, 0, 2. If I kept going this way, I'd be at 0 next. And when I got to -2 pi, I'd be at -2. So I'd be up and down and up and down, and kind of going that direction. So again, I can either 4 pi, excuse me, or 4 pi. Either one will work, but yeah, those fractional periods can really mess with you. Because dividing by fractions, sometimes we forget that it makes things smaller. Any other ones? That was a good one because it let us catch both things that we did on Friday. Yes, sir. Number 4. All right, we'll come down a little bit and we'll get to see our other period change. Oh, number 5. Gee. Now we get to see 2 things in action. Ooh, another one. I like this. We hadn't seen a negative out front yet. Whenever you have an amplitude that's negative, it's going to flip my graph. You're like, well, what do you mean it's going to flip my graph? if this were just a basic sine graph, what that would mean is this 1 would be a negative 1 and this negative 1 would become positive. It basically would take my normal curve that goes like this and make it drop below the x-axis. And that's what's going to happen. It's going to reflect over the x-axis. But then I notice my b value is 3, which means my new period is going to be 2 pi over 3. In other words, I'm going to take my base angles, and again, if you have your base angles down in your brain, it's going to make life easier. I'm going to take those base angles and I'm going to divide them all by 3. So my new angles, and I will shift this over here for the moment so we can get a little better of a view. If you have a blank graph like this, that's kind of nice because you can make all the values whatever you feel like. So if we divide them all by 3, I'd have pi over 6. I'd have pi over 3. 3 pi over 1/3 divided by times 1/3, because again we're dividing by 3, would be 3 pi over 6, or pi over 2. And then I should always get whatever my new period was going to be when I get to the end, when I get to that 5th value. So once I have that, then again, since I'm starting to get this into my brain, by the end of the week it'll be there, and I'm doing a sine graph, these would be my values except the signs are going to switch. So 0, instead of 1, this will be down at -1, and back to 0, and up to +1, because negative times a negative is positive, and then back to 0. And again, if I wanted to keep going, which I absolutely could go the other direction as well if I wanted to at this point, to fill the whole graph, I'd just be like, okay, so it seems to go up, so down. This would come up, down. Because again, I noticed the pattern, and I'm going to work that over this particular period of time. Now, if some of you are nicer and tried to do the exact same ones, maybe you're using the small lines in the middle, and that's fine too. The big thing here is just recognizing what those new angle measures are going to be and how the b value affects those. Other ones, that's 2 good ones. We got to see a flip, we got to see period changes, we got to see one with a fraction. Any other ones we want to take a peek at? We'll get them all on here again for a minute in case we're looking. Yes! Number 8. All right, let's flip over here. All right, we got another double. We have an a value or an amplitude of 3, which means those will be our maximum and our minimum values that we'll be hitting at certain points on the graph. And my period now is going to be divided by 2. So my new period is pi, which again just tells me I'm going to take all of my typical base graph measures and I'm going to cut them in half. So when I'm looking, I'd be looking at 0, pi over 4, pi over 2, 3 pi over 4, and pi. Because again, you can either think of it as dividing by 2 or multiplying by a half. So I'm going to look at those. Let me pull this over here. And since we're doing cosine, yes. So cosine, typically at 0 is going to be at 1. But remember, we have that amplitude here, a 3. So we're going to go up to 3. We're going to get our first point. This got cut in half. And it's really convenient for us that they happen to put these other tick marks in here at a real convenient spot. In between 0 and 1/2 is 1/4. And that's still going to be at 0, because even if I multiply it by 3, it's still nothing. Half of this would be pi over 2. We're going to be at -3, because we're multiplying by 3. At 3 pi over 2, 3 pi over 4, because again, I'm cutting that in half. And sometime if you're doing these, if fractions is actually a downfall for you, just keep reminding yourself, dividing by 2 is like multiplying by a half, and then I'm just multiplying across. So if I got to do a little side work to get those values, there's worse things. And that'll be back at 0. And then half of 2 pi is pi. And again, we're going to do that multiplier. And again, if I wanted to keep going, I always remember the patterns that are involved. Pi over 4. Pi over 2 is like 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4 would get me back to 0. 6 pi over 4. 3 halves. 7 pi over 4. Back to 0. 8 over 4. 2 pi. And you're like, okay, that's a complete cycle, Hardy. You don't have to go crazy here. But that's the concept. But again, it all comes from these. If you understand the base graph, the angles and the values that go with them, that's what the key is going to be for you. And these also go directly with your unit circle. So it all is going to come together. But if nothing else, if you know these, you can always make the adjustments from that and even make an extra table if you need to. Any others? Yes, sir. Okay. So one more here with 9 with an amplitude and a fraction. We'll be ready to roll here. Okay. So we got an amplitude of 2, which means we're going to be going between 2 and negative 2. And we've got a b value of a fourth. Ooh, this is going to get big. Dividing by a fourth is like multiplying by 4. Whew. My new period is going to be 8 pi. I don't know if I'm going to be able to fit all this on here. I'll try. If not, we'll get close, at least with the values that are on here. So I look and I'm like, ooh, 8 pi. So I'm going to be dividing all of these by 4. Okay, well, let's give it a shot. So my sine, I'm going to be, multiplying all these by 4, silly man. So if I'm multiplying these by 4, my angle measures. So at 0, I'd still be at 0, so that's not going to make any change. If I multiply this by 4, again, think of it like a fraction. It's 1/2 times 4, which would be 2. So 2 pi is going to give me, with an amplitude, it's going to go up to 2. And you're like, holy cow, we're out of room already. Well, we'll make a little more here. We'll at least get another point or 2 on here. So my next one, if I multiply by 4, would be at 4 pi. Be back down to 0. And we'll try to sneak one more pi in going the other direction here. So I look and I'm like, okay, I'm seeing the pattern developing here. We've gone up. This one was going to keep going downward. So negative pi would head the other direction and get me down. I should have made it further away, I'm seeing. But if I could keep going, I would see that wave. And in retrospect, when I put the 1/4 in there, I should have made these much smaller so we could have fit more on there. But that's our whole deal here. Always deal with the period first. Once you've got that period set, it's not too bad. Not too bad to get things going with those. Now, I want to take this with what we're doing with all of our sine and cosine. And I want to go back to our note sheet from Friday, this very first one we were doing, where we did the sine and the cosine graphs. I want to get you some experience with some of the functions that we don't do quite as often. I would say at least 3/4 of the time, sine and cosine are going to be where we're doing everything. But not every time. We have to be prepared for those other times. And actually, the assignment that you got today is going to have some of those other instances in it. So we're going to start down here at number 2 where it talks about the tangent. Now, there's a couple of things I'm going to let you know about the tangent. First thing, there is a period change. When you're dealing with tangent or cotangent, your period is going to be back to pi. It's not going to be 2 pi anymore. And this is going to look a little bit strange when we look at it this first time, before we start getting our base values. Check your mode. If you have a calculator from here, make sure it's in radian, because again, I got classes going back and forth. Once I'm sure of that, I'm going to change one other thing on this. Normally before, when we talked about needing a table set, if we wanted to go this route, we kept using pi over 2 because we wanted to split that 2 pi period into 4 parts. I still want to do that. So if you are going to go to a calculator to help you, your table set, okay, your change in table needs to be at pi over 4. Because if I don't go to pi over 4, I'm not going to get all of the values that I need. All I'm going to do is see a bunch of zeros and undefineds everywhere. So before I look at the table though, and again, to get to this spot, if you weren't quite ready yet before, it's just second and window will get me to the table set. But with tangent and tangent only, tangent and cotangent, we use this. The graph gets a little more interest. Oops, it'd help if I actually typed it in, wouldn't it? Tangent of x. Now I can graph it. Looks a little different from the other one. Because now basically we're going to see a whole lot of hyperbolas going on. So instead of seeing all of those curves before, we're going to see these. Now, to get kind of a grip on what we're doing here, what we're going to do is I want you to notice wherever you see the word error come up, that's where an asymptote is going to be. And that's our first inclination with this on these. So, start at 0 here. Okay, so we're at 0, 0. You're like 0.7854. What? Well, I'll come back to that. 1.57 is pi over 2. So pi over 2 is the first place that we are going to see an asymptote. So you're like, okay. And then I also noticed that at negative pi over 2, I'm going to have an asymptote. So I'm going to put our main focus into this area for right now. So I've got this 0. Well, what are these other values? Well, since they're half of the 1.57, these are my pi over 4 values and my negative pi over 4 values. So at negative pi over 4, I'm at negative 1. And at pi over 4, I'm at 1. But this isn't just a straight line I'm drawing. If I look back at the picture for a second, I notice they're coming up and then there's kind of a sharp curve and then it goes back up again. So when I'm drawing these, I want to hug the asymptote and then sort of wait till the last second and I get a nice curve out of it. And like I said, a single period for tangent is just pi. So that's an entire period right there. That's the pattern. And then what's going to happen is, if I move this calculator over here, if I were to keep going, I'd be like, oh, so right after this, here is my 3 pi over 4, my 2.3562, down at negative 1. At pi, I'm at 0, and I see the pattern develop again. 5 pi over 4, I'm up at 1. You'll never guess. 3 pi over 2, asymptote. And that would just keep going on forever and ever to both positive infinity and negative infinity. But like I said, the big things to remember with your base graph, this guy, is understand where your asymptotes are at, negative pi over 2 and pi over 2. And then we already wrote that we had a period of pi. But here's one thing you'll never really notice with tangent quite as much. In this case, I don't have a defined amplitude. Okay? I can still label points, like pi over 4, 1, or 0, 0, or negative pi over 4, negative 1. Because again, I always like having those base values to work with in case I'm asked to shift something left or right. Because then I don't have to mess with all the fancy stuff in the calculator. I just take these base values and move them wherever I'm told to move them. If there was an amplitude in front, I could just multiply the y values and leave all this alone. If my amplitude was 3, I'd have pi over 4, 3. Negative pi over 4, negative 3. And so on. So that one is the weird one of the group. But something we've still got to kind of keep track of. So as I peek over to the back, I'm actually going to go down to the bottom to number 4. Since we're on a roll with tangent, we're going to stick with it. And I also want to be able to make comparisons anyway with it. Cotangent, like we know, is the inverse of tangent, which means the graph is just going to be the inverse. It's going to open the opposite way. The period is still going to be the same. But you're going to notice in a minute, and I'm not going to write them down yet, I want us to see where they are, our asymptotes aren't going to be in the same place anymore. So we'll make the comparison here. Let me move the calculator out of the way. And here's what we're going to be up against now. So I go back in, you're like, now how do I type this in? Do I type it in as like negative tangent? No, just like what you see here, 1 divided by the tangent of x. So whenever I'm looking for any inverse, whether it's cotangent, secant, cosecant, just 1 over its inverse graph. Now let's take a peek here. Okay, so notice now when they're going up, they're not going and going up to the right. Now they're opening up and opening up to the left. It's an inverse. So when I look at these, I'm starting to go, hey, why am I getting different values here now? This is kind of strange. I'll answer that question in just a second. For now, I'm going to have you go ahead and draw these asymptotes in. Now, here's the part that gets tricky, and I want to have these side by side. So let me get these back up. What you're going to notice, and let me get the picture back up for a second. You're seeing the same thing that basically we had here with tangent, except now, instead of going here, we're going to be going this way. But here's my dilemma of sorts. Oops, chart. When I go to graph on this, my asymptotes are moving a little bit, but here's where the calculator doesn't do me any favors either. What the calculator is going to start looking at is some of these places where you're seeing error actually aren't, which is why we basically want to get a good grip right away on how to figure these out without it. And let me explain why. When I get my 0 and my pi, that's where my true errors are going to be. The ones that are in the middle, because you notice how before we had 1, 0, negative 1 with those values? The calculator, when it's doing the inverse, is getting extra undefines. It doesn't like having to deal with this that much. Because I look at the graph, maybe, and I notice the asymptotes are like at 0 and pi and so on. I don't have them every pi over 2. So I'm going to have to get myself a little bit used to the fact that now when I see error, for instance, at pi over 2, that's actually a 0. The 1 that I get at pi over 4 is still fine. The negative 1 that I get at 3 pi over 4 is still fine. But when I get that error message in the middle, it's just an issue that the calculator ends up having to deal with because of an inverse. And again, this is going to work the same way. My base asymptotes are going to be at 0 and pi. So whenever I'm shifting, I'm just going to shift accordingly. And that pattern would continue and continue and move to the left and right. But that's going to be an issue that we end up having with all of our inverses, which is why I have to have an understanding of the differences. So I look and I'm like, okay, so for tangent, those are my asymptotes. And then we just basically shift pi over 2 or 90 degrees to get the next ones. And you're actually going to find that's going to happen on these last two as well. So we're going to have to really get in tune with our base graphs. So we're going to come back up to some things we might think we know a little bit better here. Okay. Secant and cosecant. Remember on these, if you are going to use the calculator sometime, and I'd really try to get used to seeing some base graph stuff instead, if you're going to do the table set stuff on these, we're going to want to use pi over 2. So pi over 2, and I'll put this back to 0. Notice when I changed up and it went right into decimal mode. So now this is going to seem strange. Just work with me on this. What's secant the inverse of? Cosine. So for a second, I'm going to look at cosine, so I know what I'm doing here. Okay. Now, I know what cosine should look like. Now, I'm not going to connect the dots, so just stick with me here. So on a regular cosine graph, it'd be at 1, 0, -1, 0, 1, and so forth. And I'm just going to use a dotted line to let me see. Okay, this is cosine's base graph. Because I want you to see what happens when we do secant. Now, I'm not going to put them on here together on the calculator, but I want you to be able to see this graph when we graph this. So again, secant is 1 over cosine. Now visualize if I were to put cosine into the middle of this. I'm going to try it here. It might show up on here as well enough, but I'm going to try it. If not, we'll draw it in. Here's my cosine graph, and you're like, hey, it's like it hits its maxes where these parabolas are, and a minimum, it hits the parabolas down here. That's what I want you to see with this. Because when I go to graph it, what you're going to end up finding out is every time you hit either a maximum or a minimum, that's going to be where your parabolas are going to draw in. Every time you have a 0, that's where your asymptotes are going to be. Because if you think about it, if cosine's value is 0 right there, and I take the inverse of like 0 over 1, what happens? I get undefined. That's what asymptotes are. So when I get those asymptotes, then the parabolas just work off of them. And I can get my drawing. So you start to see the importance of understanding your base graph for sine and cosine, because the same thing's going to happen with cosecant here in a minute. Once I understand where that sine or that cosine graph in this case is, I can get my other values from it. And if I really wanted to get specific with some more values, because you'll notice again the calculator I didn't get very far, I can, if I want to get something smaller, go back to pi over 4. Pi over 2 and pi over 4 are always going to be the places where we get the best values. So if I wanted to, for instance, at pi over 4, we'll see if some of you have been seeing values enough yet to see this. Anybody have an idea on what that 1.4142 is as a radical? They're like, no, not yet. You will, trust me. That is the square root of 2. So, pi over 4, square root of 2, negative pi over 4, square root of 2, and then 0, 1 are going to be my base values that I was working with here. And the one other thing you're going to see mentioned whenever you're dealing with secant and cosecant is what's called a local min and a local max. And basically all that's going to mean is, as I'm going through here, whenever I see one of my graphs change direction, for instance from going down to going up, what a minimum is, I'm going to have a local minimum for this particular problem at 1. Because it's down here. I'm always looking at the mins and the maxes according to the y value. So I have a local min at 1 right here, and then here I have a local max value of negative 1. If you were asked for a coordinate, you could say pi negative 1 or 0, 1 could be your minimum or your maximum value on that. So all we're kind of doing today is kind of going into creative, kind of seeing what all of these things do. And I want you to see on this last one, because we're going to do it on cosecant too, is just see, scooch this over. We're going to do the same thing we did on this one. Cosecant is 1 over sine. So if I made my typical sine graph, so 0, 1, 0, negative 1, 0, I could go and go and go. Oh, I wasn't going to connect the dots. Bad me. I'm going to dot this back out. But what you're going to find out is the same thing that happened before, where we had our cosine graph and then all of a sudden we looked and we were like, hey, this is going to be just some connectors with it. It's the same thing on this one. So, just so I can see this in action, 1 divided by sine of x. Here goes the craziness again. And just like before, when I start looking around for my errors, I'm going to notice, I'm going to be like, oh, this looks like pi over 4 is going to work better. So 0, that worked again. I see a 0 on my sine graph. That's where the asymptote is for my inverse, for my cosecant. How convenient. And then my max and my min values are going to be where my parabolas are drawn from. And just like they were before, I've got my square root of 2 values that I'm working at pi over 4 and 3 pi over 4. My local mins and maxes end up being the same. Let me get that out of the way. So I still have local mins at 1 and local maxes at -1. And again, I can make a coordinate point out of them. But I also can get those important values out of this. So like I can get pi over 4 square root of 2, 3 pi over 4 square root of 2, bless you, and oopsie, oh Hardy, and pi over 2, 1. So that's what I'm on the lookout for here. Because you are going to be asked at times to write down critical values, which is just showing where are some points, if I wanted to graph this, that I could see those at. So now I'm trying to figure out which ones are we going to be okay with before I start giving you shifts. And I'm going to laugh when I see there's going to be none. Let's see here. Can we? Oh, and we can. Okay. We're still okay right now. It's going to be another one of those where we partial it. The note sheet you picked up today on translations and phase shifts, we'll do it starting tomorrow. For now, though, here's what we're capable of on the more graphing practice that you have here. All right, we'll keep everything straight. This is going to be the first assignment for homework check 12, so not for what we're doing tomorrow. Right now, you are okay on 1 through 7. 1 through 7 is nothing different from what we've been doing so far. Once you get past that, then it starts turning into the translations and the shifts, which we're going to start tomorrow. So we'll be able to finish that up tomorrow. So if you still have work to do to get ready for the homework check, I'd make that a priority and then knock out 1 through 7 here, and we'll jump back in with more tomorrow.